Welcome to SME College of Engineering and Research Center, Yola. Today we will study the subject Engineering Mechanics and its fundamentals. Engineering Mechanics is the branch of applied physics which deals with the study of the objects at rest or in motion under the application of forces. In this subject, we have to study the objects under two various conditions. The first condition is at rest and second condition is in motion. Either object will be at rest or object will be in motion. And to study these two conditions of the object, we have to apply the fundamental of the physics which we have already studied in earlier classes. The engineering mechanics, depending upon conditions, subdivided into two. When object will be studied at rest condition, it is called as statics. The definition of the statics is, it is the branch of engineering mechanics which deals with the study of objects at rest under the application of forces. Means in statics, forces are acting on the object, but there is no movement. The displacement is not taking place. We have to analyze the effect of that force with fundamental of the physics. Similarly, the second branch is dynamics. In dynamics, the objects will be in motion. Means the force will be acting on the object, and due to that application of forces, object is moving. The position of the object is changing. As we know that whenever the force is acting on the object, there is a displacement, and this displacement leads to the change in velocity, because rate of change of displacement is velocity, and whenever there is a velocity, there is a direct correlation with acceleration, because the rate of change of velocity is acceleration. Again, in different conditions, there are different variables. The dynamics is subdivided into two categories. First is kinematics and second is kinetics. Kinematics and kinetics. What is meant by kinematics? Kinematics is branch of engineering dynamics which deals with the study of objects in motion without considering force causing the motion. We know that there are number of cases in which we only require the effect of applied force. How much force is acting on the object? What is the direction? What is the magnitude? All these details of the force is not required. We only concern with the effect of that force. Means we are not considering the force acting on the object. But analysis is done of moving objects. These type of the problems will come under the category of the kinematics. It is a branch of engineering dynamics which deals with the study of the objects in motion without considering force causing the motion. Similarly, there is another sub-branch, kinetics. The kinetics is defined as, it is the branch of engineering dynamics which deals with the study of objects in motion considering force causing the motion. Means in kinetics, we will study displacement, velocity, acceleration, jerk, retardation, all the variable of the motions, along with the force acting on the object. Means the basic difference in these two branches are, in both we will analyze the effect of force, but in one we will consider the force causing the motion, that is called as the kinetics, and in one branch we will not consider force causing the motion. That comes under the category of kinematics. The basics of engineering mechanics are to analyze kinematics, kinetics, statics. We require fundamental laws of the physics, and the fundamental laws of the physics are we are studying from secondary school, but we know the definitions, but how to apply in practical situation on the object we will study in engineering mechanics. Already you know that what are the fundamentals of the physics, but the very important points we will brief in a very short time, that is Newton's laws of motion. We know that there are three laws: Newton's first law, Newton's second law, and Newton's third law. The definition of the Newton's first law is every object continues its state of rest or uniform motion until and unless it is affected by some external force. Means the position of the object and uniform motion of the object will not change until and unless it is get disturbed by some external agency. In other words, the Newton's first law can be described as the algebraic sum of the forces acting on the object is zero, because until and unless there will be unbalanced force, then the moment will take place. If unbalanced force is not acting, the motion of the object or stationary condition of the object will not change. This Newton's first law we will use in unit number 1 and 2 of engineering mechanics. Then along with that Newton's first law, Newton's second law is also very important. We already know that whenever Newton's second law has been asked, we are saying F equal to ma, means force equal to mass into acceleration. Force is the product of mass and acceleration, but actually this F equal to ma is mathematical representation of Newton's second law. Newton's second law states that the algebraic sum of the forces acting on the object is equal to rate of change of momentum. Means whether one force, 2, 3 or number of forces are acting on the object, the algebraic sum or the resultant of that force system is equal to rate of change of momentum, and the momentum is the product of mass and velocity. So F equal to d by dt of mv. According to law of conservation of mass, we know that the mass is constant, so we keep it aside, m d by dt of v, and we know that this dt by dt is rate of change of velocity, which is acceleration. Therefore, the equation will become F equal to m. This Newton's second law mathematical expression is very important. Along with that Newton's first law, we will use this expression and the concept of the Newton's second law in unit number 2, 3, 4, and in some points we will also use in unit number 5 and 6. The third Newton's third law, which is very important for engineering mechanics. In all the units of the engineering mechanics, in different kinds of the problem, we will use Newton's third law, which is very famous. All of us is well known to Newton's third law. That is, every action has equal and opposite reaction. Action and reaction is the part of the life. Actually, in nature, without reaction, work cannot be take place. Whenever there is a action, the reaction is compulsory, and that reaction will be in opposite direction of action. These three laws we will use in engineering mechanics, and the very important quantity of the physics, which is force. Force is fundamental quantity on which all these laws are working. And in all unit of the engineering mechanics, we will see the forces and its effect. What is meant by force? The force is the external agency which impeding the object to change its position. The unit of the force is Newton. Newton is the unit of the force. And 1 Newton, actually what is meant by 1 Newton? The 1 Newton force, the force when acting at 1 kilogram of the object and producing the unit displacement, then the applied force will be considered as a 1 Newton. Means the object has the mass of 1 kilogram, force is acting, and due to the application of the force, the displacement in the object is 1 meter, then the applied force will be considered as 1 Newton. In engineering mechanics, when we will move from unit number 1 to 2, the complications and the difficulty will increase. Means in first unit, we will only deal with the collinear forces. What is meant by collinear force? Whenever the forces are acting along the same line, then the force is called as a collinear forces. And whenever on the object number of forces are acting, means more than one forces, then that number of forces comprises a force system. When single force is acting, we are saying force. But when number of forces, these number may be unlimited, 2, 3, 4 or n number of the forces, then that all forces are comprised as a force system. There are different kinds of the force system. The first and very important thing is we should know what are the different type of the force system. The first force system is coplanar force system. Coplanar force system. Coplanar force system, then non-coplanar force systems, then concurrent force, non-concurrent force, space force, parallel force system. These are the some various force systems. What is meant by coplanar force system? As already we know that there are 3 planes. Generally we deal only XY plane, but there is another plane, that is XZ plane. Means in nature there are 3 planes: XY plane, YZ plane and XZ plane. Whenever all the forces are acting on the object lying in same plane, then the force system is called as a coplanar force system. The direction and the position of the forces are in single plane. When number of forces are having position in different planes, though acting on the same object, but having the position and the direction in different planes, this force system is called as non-coplanar force system. The force which is acting on the object producing the effect, when the point of application of force is not a force, because whenever we are studying system, means it is more than one force. Whenever the point of application of forces is single point, then it is called as concurrent force system. And when the point of application of forces are different, it comes under the category of non-concurrent force system. Then there is one another type, that is space force. In space force system, the forces are lying in three-dimensional, means some forces will lie in XY plane, some forces will acting in YZ, XZ. In all three planes, the forces are acting. Then it comes under space force system. Then parallel force system. Whenever the line of action of the forces are parallel to each other, the force system is called as a parallel force system. In parallel force system, there are two possibilities. The first possibility is these two are the parallel. The first possibility is the direction of force, because we know that the force is a vector quantity, and to describe the force vector quantity, we require magnitude as well as direction. When the direction of both parallel forces is same, then it is comes under like parallel force system. Like parallel force system. But when the force direction are different, means both forces are parallel, but direction is opposite, this force system is called as unlike parallel force system. Then there is one another type of force system, that is collinear force system. Collinear force system, it is seventh type. In collinear force system, the line of action of all forces are lying in a single line. The best example is tug of war. Both of teams are applying the force along the rope. Though that point of application is different. This person is applying at this position, then at this, all four forces, point of application is different, but line of action is same. The direction is not important in collinear forces. Only means whether it is rightward or backward, no issue. Only the line of action should be in a single line. And the line of action has a very important role. What is meant by line of action? A line of action of force is an imaginary line which can be extended infinitely. Means if force is acting at this position, then this dotted line is a line of action. We can extend infinitely in forward direction as well as in backward direction. To analyze this all force system, this line of action is very important. Very important. Along with these fundamentals of the physics, laws of the physics and the force system, there is one law which is called as a law of transmissibility of force. Law of transmissibility of force states that a force can be shown anywhere along the line of action. The effect of the force does not change. Means, for example, a force F1 is acting at point A. The line, I will extend the line of action. Line of action is an imaginary line which can be extended infinitely. It is an imaginary line. Law of transmissibility of states that this force F1 can be shown anywhere along the line of action. Effect does not change. The best example is we often go in the mall or in the offices. Then on the glass door, pull or push is written. One side if there is a pull, then another side is a push. The effect is same. Either means if it is a glass door, it is a push, and at the same time, same force if we apply along the line of action, it is a pull. Means nature is changing, but in both the cases the effect does not change. The law of transmissibility of force can be proved with the help of the principle of the superposition. Very simple. We will see the principle of the superposition in this figure. Assume that this point is B, and I will add and subtract two forces of same magnitude but opposite in direction at point B. The total overall force system is not changing because force F1 acting at B is cancelled by force F1 of opposite direction. It is same as if A equal to B, then 2 plus A is also equal to B plus 2. If both the signs you will add and subtract, there is a no change. Now listen here, hide this third force and see these two forces. These two forces, though point of application is different, this force F1 is acting at A, this force is acting at B, but having the same magnitude, acting in along a same line, is collinear forces. Both are cancelling each other. Both are cancelling each other. That's why in third figure the effect force F1 will be shown at point B. You can see that the force F1 which is acting at point A is now transferred at B without changing the system of the forces and the effect of the force system. The law of transmissibility of force is used in unit number 2, unit number in 1 also we will see some application in unit number 2, unit number 3, and in last unit just we will use law of transmissibility of force. The very important thing is that along the line of action we can slide the force without changing the magnitude and direction. Whenever there is a vector quantity, there are three types of the vector quantities. The one is the fixed vector. Fixed vector means if we change the location of point of application of quantity, then the effect will change. Means it is a fixed. Moment is a fixed vector. There is one another type, sliding vector. In sliding vector, the quantity or the vector quantity can be slide along a line. Like force is a sliding vector, means saying this force F1 is acting at A is not change the position at B with same magnitude and direction, and effect is not changing. Means in this case, this force F can be slide along the imaginary line, that is line of action. So some quantities are comes under the sliding vector. There is another third type of the vector is free vector. Free vector. Free vector are the vectors if we change the position of the vector, the effect doesn't change. Means either we can show it as at point A or at point B or at some other point. The effect of that vector will not change. The best example of free vector is couple. These are the three kinds of vector: fixed vector, sliding vector, and the free vector. Depending upon the type of the vector, we can simplify the numericals in practical applications. Because in practical applications, in some cases you will see the force system is composed of linear forces, moment, and the couple. So for analysis, if it is a free vector couple is acting, then we can change its position because its effect and the results on the object is not changing. So today's we will summarize the important point of the today's lecture. We have to remember the definitions of engineering mechanics, statics, dynamics, then kinematics and kinetics. We have to remember types of the force system, types of the vector, force, free vector, fixed vector, sliding vector, and different types of the force system. Now from second lecture we will see the application of this concept which we have studied today. Thank you.